Our new entry is on two-way tables, and it's just another type of table that you're going to have to be able to read and pull information from, kind of like pulling in information from a graph, but now we're given a table. So normally when you see tables, you see something like this, right, with gender and then maybe male and female, and it's just got two different categories to separate, right, either you're male or you're female. Okay. Now, when you have two-way tables, there are two sets of categories. Okay. There's orange juice with a yes or no, and there's gender with the male and female, or whatever situation is in the problem. So this is just another way to kind of pull information and identify what number means what. So when I look at this two-way table and I see this 12, I know that it falls between male and no, right? The 29 falls between the female and yes, right? So 29 are probably females that like orange juice, and 12 means males that do not like orange juice. Okay, so when we look at this problem, and it says you randomly survey students about whether they like orange juice, the two-way table shows your results. How many female students in the survey like orange juice? You're going to find female, right? And yes, they like it. And that number brings you to 29. So 29 females like orange juice. In this problem here, it says find and interpret the marginal frequencies for the survey above. So we've got some vocab to go over. What does marginal frequency mean? So marginal frequency are basically the totals. Okay. So find and interpret the totals. So what we're going to do is we have this this situation here of students that studied and did not study, and whether they passed or they failed. Now, given that situation, how can I find the totals? Well, I'm going to add in some boxes here because they don't leave me any. And this is where I'm going to write my totals. Okay, so let me start kind of writing them in. 21 and 2 makes 23. 1 and 6 makes 7. 21 and 1 makes 22. 2 and 6 makes 8. Now, if I did this correctly, that means that 23 and 7 should be the same as 22 and 8. And in fact, they are both 30. Okay, so I added everything together correctly. Now, if I added these and I got 29, then I probably have a mistake here or here, right? But because they total to the same amount, the 30 is consistent, which means I probably added my totals together correctly. And it's great knowing what the totals are, but it asks us to interpret what those totals mean. So what does the 23 represent? Well, 23 is the total that pass. So 23 students pass. 7 students failed. Right. Here, how many studied? Well, 21, 1, so 22 students studied. Eight students did not study. And the 30 represents the amount of students that were surveyed. For this problem, we're going to be asked to take this information, these tally marks, and make a two-way table. So you randomly survey students between the ages of 12 and 17 about whether they ride the bus to school. The results are shown in the tally sheets. Make a two-way table that includes the marginal frequencies. So, two-way tables means that I need two sets of information. What are my sets of information? Well, I have rides bus, and I have does not ride bus. Okay, so that's one set. And then each of these have an age, right? So a category of ages. So those are going to be my two categories, or my two sets of data when I start creating this two-way table. Now I have my outline of my two-way table. So I have my marginal frequencies here, right? My two different sets of information. I've got students that ride the bus or don't ride the bus, and then I've got age groups 12 to 13, 14 to 15, and 16 to 17. Okay, so I'm going to use two different colors. Blue is going to be my regular information here, right, where I'm counting up those tally marks to see how many age between 12 and 13 ride the bus. Green are going to be those marginal frequencies. Okay, so as we start to look at this information, all these tally marks, let's start with rides bus. So that's this top row here. And you may have done yours this way, with the students on the top and then maybe the age on the side. That's fine. It shouldn't make a difference. We'll still get the same totals and the same information in the boxes. So rides bus, that's this one up here. So tally marks here, we've got 5, 10, 15, 20, 21, 22, 23, 24. So 24 students that are aged 12 to 13 ride the bus. Right? Age 14 to 15. 5, 10, 11, and 12. 16 to 17 is 5, 10, 11, 12, 13, 14. And that's the rides buses. That's that information I pulled from this table here. Now this one does not ride bus. So 5, 10, 15, 16. So again, I'm just counting up the tally marks and putting them in the boxes here. 5, 10, 11, 12, 13. And then 5, 10, 15, 20, 21. And there we go. So those are my data that I've taken just from this tally sheet, and I put it in a nice, easy to read table, so I don't have to count any tally marks. I can right away see that there are 14 students that ride the bus that are aged 16 to 17 who were surveyed. So now I want to include the marginal frequencies, right? That's the totals. So we're going to add these up. 24 plus 12 is 36. Add the 4 from here is 40, and then the 10 makes 50. 16 and 13, and 6 and 3 is the 9, so 29. Add the 1 brings me to 30, and then the 20 makes 50. And again, now I add this way. And these are kind of stacked on top of each other, so I can do 6 plus 4 is 10, right? 20, 10, 10, so that's 40. 12 and 13 makes 25. 14 and 21 make 35. Okay. Now, just like before, I want to make sure I added correctly. So 40 and 25 is 65. Add the 5 is 70, and the 30 makes 100. 50 and 50, 100. So both totals get me to 100, which means I've probably added those correctly. Now this one doesn't ask me to interpret the marginal frequencies, but if I were to, I would say, out of the kids that were surveyed, 40 of them were aged 12 to 13. Or I might say 50 of them do not ride the bus to school. Okay, so that's how I would interpret those marginal frequencies. Right? 100 students were surveyed. This last example, I'm asked to use the two-way table from example 3 to help me solve this problem. So, For each age group, what percent of the students in the survey ride the bus to school? So I want to take a look at my table here. And for each age group, right? Each age group, so this one, and this one, what percent rides the bus to school? Okay, so we're also asked does not ride the bus to school. So we're asked multiple things. So what we're going to do is we're actually going to make a table, but instead of this raw data here, we're going to put in percentages. And I'll show you how to do that right now. What we're going to do is first copy this table down. Okay, you don't need the marginal frequencies here, but you're going to copy this table down without these raw data put in, just kind of the shell of the table. And you'll see what I mean in a second. So as I was saying, we wanted just the shell because inside of these boxes, we're going to put in the percents. Okay, so it's asking what percent of students, right? Percent of the students, okay, ride the bus to school or do not ride the bus to school, and it's asking for each age group. So when we look at these, we're not really looking at combining all these age groups together and using the totals that are here, right? We're looking just at the individual age groups. So what we would do is, if we're looking at 12 to 13, we're going to kind of cover up everything else. And what's the percent of students that ride the bus and don't ride the bus for just 12 through 13? Well, there were 40 students that were between the ages of 12 and 13 that were surveyed. 24 of them rode the bus. So in our cell here, we would put, right, 24 over 40. And then we'd want to give that as a percent. So what is 24 divided by 40? And then 14 to 15. So if I look at the table between ages 14 and 15, the students that rode the bus were 12. And there were a total of 25. So right here I'd put 12 divided by 25. And that's 48%. Right. Here, 14 out of 35. That gives me 40%. So that's how I'm finding these percentages. It's the total, right? I'm using the total that's down here. Right? As my whole, and then my part comes from the table above. So if 60% ride the bus, that means that 40% do not ride the bus, because these need to add up to 100%. Right? If you wanted to just make sure that that's true, you can simply do 16 divided by 40, and that'll give you 40%. And I keep going with these. That's 40%, 52%, and 60%. That's how I fill out these percentages here. So Part B asks, does the table in Part A show a relationship between age and whether students ride the bus to school? So what is the relationship here between age and whether or not students ride the bus? I would say that it does show a relationship. As the age increases, right, the students are going to be less likely to ride the bus. Look how it goes, 60 to 48 to 40. So, yes, as the age increases, students are less likely to ride the bus. And that's all of the examples for two-way tables. So if you have some on the back, some on the front, and for mine I've got some space in between here. So what I'm going to do is I'm just going to put a piece of tape right here so that it will fold just like a book. And there you have it. So it folds up. Right, I can flip it just like a book. And that is the very last entry for this unit. So at this point you're going to want to start studying, because there's quite a bit in this unit. We actually went over 3 different chapters. We did chapter 4, chapter 6, and chapter 9. So there's a lot to it. Definitely going to want to do a lot of review to prepare for your test.